Okay. Is it audible? Hello.
Yes, sir.
So good afternoon to one and all. I welcome you all for the electrical measurement and instrumentation practical. We have already started the experiment number 1 is over in the previous laboratory. We have studied the measurement of resistance. The measure we have already discussed about that one. So today we are going to discuss that is experiment number 2. If you want, you can take that one. Experiment number 2. We are going to discuss about the measurement of medium resistance by using Wheatstones bridge here. So actually it will comes under third unit, that is called potentiometer and bridges here. Now actually the bridges have the advantage that it will give the accurate answers of the resistance, inductance, capacitance. The bridges are classified into two types, is DC bridges and AC bridges. So this Wheatstones bridge is actually DC bridge. I'll discuss in the theory part, we'll discuss that one. But whatever the required thing is there to do the perform this practical, I'm going to explain that much here now. In the theory classes, we'll discuss deep over there. Okay. So the experiment number 2 is measurement of medium or high resistance. Actually, medium resistance only it is applicable. Medium resistance by using Wheatstones bridge. So the main aim of this experiment is to measure the unknown resistance by using the Wheatstones bridge here. So Wheatstones has derived one bridge circuit to measure the unknown resistance. So the name came, that is Wheatstones bridge here. So that bridge circuit we are going to do the perform in the practical here. So to perform this practical, what are the components required? So first one is the kit is available, that is whatever the Wheatstones bridge kit where we have to connect the resistance 1, 2, 3, 4, we have to connect that one. That kit is required. After that one, the resistances boxes are required, variable resistances if it is applicable. Digital multimeter to measure the voltage, how much voltage is there, and connecting patch cards, whatever the patch cards are there, these are the connecting patch cards. These are required to connect that one over there here. So these are the components required to perform the practical here now. This is the circuit diagram here now. See here, R1, R2, R3 and R4 resistances. 4 resistances are connected in the form of bridge circuit here now. I think you have studied in the galvanometer circuit, the physics subject, you have studied this one. So 4 resistances are connected in the form of bridge, and in between two resistances, 2 terminal, one galvanometer is connected here now, which is a very sensitive element is used. The sensitive detector also we are going to call for the galvanometer. If the bridge is not balanced, then the galvanometer will deflect. If the bridge is balanced condition, then the no current will flow through this galvanometer. So it will act as an open circuit. It will act as an open circuit. I don't know how many people you know about this here. So do you understanding balance condition? The balanced condition means the potential difference at this point to here should equal to the D to A also here. This is the main point where the galvanometer is connected. Galvanometer is connected to the B to D it is connected. So the bridge will be balanced if VAB equal to VAD equal to VAB, whatever it may be. VAB equal to VAD or VAB equal to VAD or where is the another 2 terminals are connected here now? Here B to C and C to D. If the potential drop across B to VBC is equal to VDC here. So then also we can say that the bridge is under balanced condition. We can say that one here. So it is connected at B and D here now. So potential difference between this point B and point D should be equal. Then the current flowing through this galvanometer will be 0 here now. So it will act as open circuit, or there is no galvanometer at all. Like that, the galvanometer deflection will be 0. On that condition, we are going to show that one. We are going to tell that the bridge is balanced here. No. The bridge is balanced here. No. Understood? Do you understood what do you mean by balanced condition?
Yes, sir.
Okay. So based on this, for this particular circuit diagram only, we are going to do the practical here now. Today we are going to do the practical here now. See here, this symbol, it indicates that variable resistance here. Now this is the fixed one we are going to use. Here the R1, R4 also fixed we are going to use. R3 also fixed we are going to use here now. Out of these 4 resistances, any one resistance we can consider as unknown resistance. We can consider that one. Can consider as unknown resistance. See here. So which one is variable, which one is non-variable here? No, this is the standard resistance we are using here. The R2 is standard resistance. R1 is variable. We can vary that resistance while doing the practical here now. We can set that one any value here now to bring the bridge to balance condition. R3 also we can vary that one here now. And R4 I can consider as unknown resistance here now. I can consider as unknown resistance. R4 I can consider as unknown resistance, this one. Okay, so the battery supply is connected to the A and C here now, and the galvanometer is connected between B and D here now. All the 4 resistances are connected in the bridge form with galvanometer and DC power supply. So I told 4 resistances are there here. This one standard resistance, it is a variable resistance is there. This is also variable resistance. This one I have considered as unknown resistance. Then we have to derive the formula for R4 here. No, we have to derive the formula for R4. So for that reason, we have to do the derivation here now. In simple form, I will tell the derivation here now. Considering the circuit also, considering this circuit diagram only here now, which current is flowing here? The current flowing through the R1 is I1 here now. If the bridge is balanced condition, then the galvanometer के through current flow हो रहा है क्या? If bridge is balanced, no current will flow. So same I1 current will flow through the R3, R2 also. Here, whatever the I3 I am using here now. So at balanced condition, can I write like this? I1 equal to I3. Can I write like this? At balanced condition, I1 equal to I3. Same current is flowing here.
Yes, sir.
Yes or no? Same current is flowing here. No. So I1 equal to I3 we can write here. Next, at this condition, I2 equal to I4 I can write here.
Yes, sir.
I2 equal to I4 here. I2 equal to I4 we can write here. We can write. Actually, they have done one mistake here now. This one they have to consider as R3 and this one they have to consider as R2. Then it will become easy. The current flowing through the R2 is I2 like that. Okay, whatever it may be. दोनों same ही है, कुछ भी consider कर सकते. So, according to this, we can call that the voltage, the bridge will be balanced at this voltage drop across this one equal to voltage drop across this one here. So voltage drop across R1 according to Ohm's law, we can write I1 R1. Voltage drop across R1 equal to I1 R1. Yes?
Yes, sir.
So I1 R1 equal to voltage drop across this one. R2 we can consider here. This one you consider as R2 and this is R3. R2 here now. So voltage drop across this R2 equal to I2 R2. You can write like this.
Yes.
I2
Yeah.
R2. So if both this potential difference is equal, then the galvanometer is current flowing through this one will be 0. So it will balance condition here. Now I will consider I1 R1 equal to I2 R2. That is equation number 1 here. Equation number 1. Similarly, already I told that one I1 equal to I3. I2 equal to I4. So I1 equal to I3 equal to what is the total voltage drop here? This is E here now. E divided by, if same current is flowing R1 and R3, then R1 plus R3 we can write. The resistance, total resistance is R1 plus R3 only, na? Yes or no? If I1 equal to, just a minute, I will erase this part. If I1 equal to I3 equal to voltage drop across this one, I1, both here, these two same current only flowing here. So R1 and R2 both are in series. R1 and R3 are in series or not?
Yes, series.
Yes. So according to Ohm's law, V by R, I equal to V by R. So V is nothing but total voltage is E here now, divided by, what is the resistance here now? R1 plus R3. You can write like this. R1 plus R3 for this I1 and I3. Similarly, so here we have written I1 equal to I3 equal to E divided by R1 plus R3 here now. This one I will consider as equation number 2. Next, similarly, I2 equal to I4 equal to E divided by R2 plus R4. That one I have considered as equation number 3 here now. Equation number 3 here now. Row number 15. Okay. So here equation number 1, 2, 3. Three equations we have calculated here. No, the E is nothing but battery supply or EMF of battery. We can tell that one here. No, what is the equation number 1 here? I1 R1 is there equal to I2 R2. Here in the place of I1, can I substitute equation number 2? I1 का place में ये substitute कर सकते? Yes or no?
Yes, sir.
In the place of I1, we'll substitute this equation number 2. In the place of I2, we'll substitute equation number 3. So combining equation 1 and 2, we will get here now equation 1, 2 and 3 also. Combining equation 1, 2 and 3, we get here now I1 का place में क्या है? E R1 by R3 into R1 here now equal to I2 का प्लेस में क्या है? E R2 divided by R3, sorry, R2 plus R4 into R2 here no. So both side LHS side RHS side E is there, E will get cancelled here no. So R1 divided by R1 plus R3 equal to R2 divided by R2 plus R4 is the left term here now. So by rearranging the equation, we are going to get the final equation, that is R1 R4 equal to R2 R3. By rearranging the equation, we are going to get this one here now. I don't know how many of you are understanding or you are getting the confusion. Means I can write here this equation. It will be like this: R1 divided by R1 plus R3, R1 plus R3. इसके आधा घंटे में हम प्रैक्टिकल भी करना क्या वो भी याद रखो. R2 divided by R2 plus R4 ये इक्वेशन हमने ऐसा लिख सकते. This R2 in plus R4 you send into LHS side, it will multiply into R1, and R1 into R2 you send into this side, and rearranging the equation plus minus करके LHS to RHS by substituting and equating these all the equations, rearranging the terms, we are going to get the final equation, that is called R1 R4 equal to R2 R3. ये equation हमको आ जाएगा. This is the equation for the bridge at the balanced condition here. If the bridge is balanced condition, then R1 R4 equal to R2 R3 we are going to get here. From the circuit, which one is the unknown resistance? Which resistance is unknown here? Which resistance is unknown resistance?
R4.
R4 is the unknown resistance. From this equation, we can write the R4 equation. From equation number 5, can you tell me the R4 equal to what? R4 equal to? I am asking to you people only. Here the R4 is there. R4 term keep as it is. The RHS I will write R2 into R3 divided by, when R4 I will send into RHS side, it will become denominator R1 here. No. So R4 equal to R2 R3 divided by R1. You can write like this. Yes.
Yes, sir.
Can write like this, or we can use this R1 as unknown here. No. So R1 equal to R2 R3 divided by R4. Can write like that also. So under the balanced condition, R1 R4, this R1 and R4 both are opposite resistance here. Now multiplication equal to R2 and R3. We can remember like this, or you can remember the formula like this also. R1 by R2 equal to R1 by R2 equal to R3 by R4 also. R3 by R4 also. Yes. R1 by R2 divided by R equal to R3 divided by R4 also. This is also correct answer. You can remember any different methods are there. You can remember anything here. Any method you can remember. So the unknown resistance formula, all of you note down this formula. R4 equal to R2 R3 divided by R1. You note this formula here. Note down here. So we are going to do the practical, means you have to sit down with pen and paper. Observation table is there. I am not going to use the readings. You have to note down and you have to write in the write up part. Over. So this is the formula we are going to consider here. Next, what we will do, we'll discuss about procedure here now. As per the kit, we have to do the connection as per the circuit diagram, and we have to switch on the supply. Connections are made as per the connection diagram. Connect the decade box and all the things I will explain with the kit. This procedure I will explain with the kit. Okay. So this is the observation table we have to note down here now. Serial number R1, R2, R3, R4 here now. So R1, R2, R3, these are the known value we have to consider from the kit. R4 practically kitna hai? Theoretically how much, after calculation how much we are going to get here. This is the observation table. You note it down. Note down kar rahe kya nahi?
Pending fees. Yes, sir.
हाँ, रुको थोड़ा वीडियो करना है, प्रैक्टिकल है. Okay, कैसे भी आए, ठीक है. I will note down this one observation table. Don't write these readings. I'll give different readings now. Only serial number R1, R2, R3 and R4 practical, R4 theoretical here. Serial number 1, 2 readings I am going to give here now. Okay, this is the observation table. Next, precautions what we have to do, we have to check the all the connection before switching on the supply. Note all the readings accurately. Avoid the loose connections we have to avoid. And for the calculation purpose, this is R1, R4 equal to R2, R3. This formula we are going to use here. So after taking the reading and all the things, we can tell that one, the unknown resistance is measured by using the Wheatstone bridge. That is the conclusion. So based on this, we are going to perform the practical now. We are going to perform the practical. Now here, I will join by mobile and I will switch over there. Just a minute. I'll stop this one. I will remove. Stop sharing this one. एक वीडियो करना है मैडम.
हॅलो, तुम्ही किती भरलेली फीस?
Visible screen is? Just a minute. I will go and I will show the kit to you peoples. Only this practical we are going to do hardware. Is it audible or not?
Audible,
Hello?
sir.
Okay. See here. The kit is visible?
Yes, sir.
Just a minute. Okay. So this is the kit we are going to discuss here now. See here. Here the variable resistance R1 is there. Here the R3 is variable and R2 is the fixed value we are going to use. R4 we are going to connect here, that is unknown value. So unknown values, two values they have given. One is 5K, another one is 10K here now. So out of these two, any one we can use. So in between the galvanometer is there. This connection we have to do here. The galvanometer connection here. See in the circuit, they have shown here dotted lines are visible. These dotted lines. This indicates that there is no connection inside that one. We have to do the connection manually by taking these patch cards. By connecting these patch cards, we have to do the connection. This dark line, it indicates that it is already connected internally. It is already connected internally here now. See here, R1 is variable they have shown. Variable they have shown means this one by using here, see three decade boxes are there, 1, 2, 3. This by using this one, we can vary here now. So here we can consider this one, 1 point into 1E. 1E indicates that is ohm here. Now 1 into 1, how much? 1 ohm. 3 into 1, 3 ohm.
3.
Like that here. Here 10 is there. So 5 into 10, 50 ohms here now. And here I will increase this one 2 here now. 2 into 100, that is 200 plus 50 plus 3 here now. 253 total we have to count like this here now. This is variable resistance of R1 here now. R1 we are going to vary. Next, here the variable R3 they have shown here now. That is called R3. We are varying by using this decade box here now. Here 10 into 100K is nothing but 1000 kilo ohm plus 10 kilo ohm plus 1 kilo ohm. Sorry, 10 into 10, 100 kilo ohm, 10 kilo ohm. This is 1 kilo ohm. This is 100 ohm into 10 ohm here, plus 10 ohm. This is all addition. It will give the total resistance of R3. Here R1 we are going to count here now. And here, see here, R2 resistance, they have given already three resistances here now. If we have considered this point and this point, it indicates that is how much is there, 330 ohm here now. The middle red one and blue one I have connected, that is 560 ohm. If I have used the last one, that is black patch, that is nothing but 1 kilo ohm is there. Like that we have to do the kit here now. Okay, so these are the unknown resistances. Here the points we have provided for the galvanometer here now. The key, the switch we have provided here now. This is open and close here. Is it clear? The kit is clear. Can I do the connection now?
Yes, sir.
Yes, sir.
Hold it, madam. See here, I will take the patch cards. First, I will start here now. R1 connection I will do. R1 to where it went? R2, na? R2 I will connect here now. R1 to R2. So R2 to another resistance that is called here. R2 I will consider as 560 ohm now. R2 I will consider as 560. From here to here we have to do the connection. Okay. Next, R1 and R2 connection is over now. R3 connection I will do here. R1 to here we have to do. Next, bigger patch cuts. This one, R2 we have done here, no? Patch cuts coming here. Okay. Next, I will take two patch cuts here. See here. Two patch cuts. One R3 and another one is here. R3 have connected here. So R1, this one connection is over. This connection is over. This connection is over now. So what we have to do next? We have to do the connection for the R4 here now. R4 is this one. One terminal I will take here now. R4. R4 I will take one terminal. That is, and I will take 5 kilo ohm here now. So I will consider this one. Another terminal of R4 I will consider, and I will connect to this 5 kilo ohm here now. So this is R4 connection is over now. So the left terminal is galvanometer connection is left here. Now I will take two patch cards. I will take two patch cards. See here. Here, one terminal, another terminal connect here. Then the positive, negative, you have to connect here now. The upper sides here now. Okay. So these are patch cards are actually bigger. I have checked that one. All the knobs are connected to 0 or not. I will check that one. So connection is over now. We'll check that one if it is correct or not. I will switch on the power supply. I will close the switch. So it is at 0 now. It is at 0 now. Here the galvanometer is 0. So it is nothing but there is no current flowing at all because there is no resistances. All the resistances value we have considered 0 only here. So what I will do, I will vary some resistances. Somewhere is mistake is there then. Just a minute. Hold it. So R1 we have done here to here. This one. Just a minute. Loose connections are there. Not that much problem. Here we have not closed this switch. The switch is open now. Here now. Suddenly, whenever I will close this switch, the bridge is unbalanced condition now. Galvanometer 0 का है क्या अभी? It's not there at 0. Yes?
Yes,
Is
sir.
it audible? So the galvanometer is unbalanced now. So I will bring all the resistances 0 again. See here now. It is 0 now. All the resistances I have brought into 0. Then some variation is there. I will consider that 1, 2. So by varying the resistances R1, I will bring that one into 0. Here, the bridge is coming balanced. It is there at 0 now.
Yes, sir.
Yes, still little bit is there. Now you check it. It is 0 now. So the bridge we have brought into balanced condition. Now what I have to do? We have to note down the values now. What is the value of R1? What is the value of R2? What is the value of R3 here now? So I will take here now. Here I will write R1, R2, R3 here now. I will write R1 value. See here, R1 value we have to consider first this one. How much is there? 1, 2, 3, 4, 5, 6, 7, 8. 8 into 100. So R1 equal to 8 into 100 plus next this one, it is already 0 is there. 1, 2, only 1 is there. So 1 into 1, that is called 1 here now. So 8 into 100, how much? 8 into 100, 800 plus 01. It is nothing but 801. 801. R1 equal to? Yes?
Yes, sir.
8 into 1, 801 here now. Next, R2 equal to how much we have chosen here? What is this value? 560. So 560 ohm I will consider here now. Next, the main important thing is R3 we have to consider here. R3. This one is 0 is there. This one 0 is there. Here 1, 2, 3, 4, 5, 6, 7. 7 into, that is 1k is nothing but 1000 plus hold it, 1, 2, 2 into 100, that is called 2 into 100. Next 1 into 10 plus 1 into 10 plus 1, 2, 3, 3 into 1 plus 3 into 1 here. So we can write this one 7000 plus 200 plus 10 plus 3. What is the total? 7213 ohm here now. 7213 ohm. Okay. Now I'll write the formula R4 equal to R2 by R2 R3 divided by R1. Substitute R2 equal to how much is there? 560 is there. What is the R3 here? 7213 divided by R1 is 801. Calculate this one. Calculate. How much it is? Calculate. Do the calculation. 560 into 7213 divided by 801. How much it is? 5042. Yes or no? 560 into 7213 divided by 801 equal to how much you got?
5054.
5054 or 5042 I got actually. So R4 equal to, we can write this one as 5.04 kilo ohm. Yes. So here 0 is there. 1, 2, 3. 5.04 into 10 to the power of minus plus 3. Plus 3 is nothing but kilo. Yes. 5.04 kilo ohm. We can write like this. Yes or no?
Yes, sir.
Okay. How much R4? This is the calculated theoretical value calculated here now. But how much ohm we have used here now? The R4 equal to, in the practical, how much we have used? What is this value?
5K.
5K. So 5K is the practical. 5K is there. Here the theoretical value 5.04K is there. So both are matching here now. Yes. Both are matching or not?
Not.
Not. It is negligible. 0.4 is negligible here. No. So 5.0 is nothing but 5K and 5K. We can say that one. Both are similar, na? Nearer value only, na?
Yes, sir.
Yes or no? That is negligible. The negligible value. This is 0.4. We can consider as negligible value here now. So the practical and theoretical values are matched here now. Similarly, we have to take. I will take another reading here now. This is one reading. All of you note down this one. These all the readings you have to note down. This one you have to write in the practical, and in the theoretical you have to write this one value. Next, what I will do, I will uh, switch off the supply. Instead of 5K, I will use 10K now here. Now I will use the 10K. R4 equal to 10K. The practical value is 10 kilo ohm. I will use here now. So 10.2, 10.1, like that we have to get here now. So I will switch on the supply. I'll switch on the supply. All the values are noted down here. We have to bring the bridge into 0. So it is 0 now. Okay. So again, bridge came to the balance condition. I will open the switch. I will switch on now. So again, I will note down the value of R1 here now. R1, R2, and R3 here now. Same value we have to note down here now. CM R1. R1 equal to, first I will consider this one. 1, 2, 3, 4, 5, 5. 5 into 100 plus 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 into 10 plus, that is 0 is there. So 5 into 100, that is 500, plus 10 into 10, that is also 100. So total is R1 equal to 600 is that here now. So R2 equal to, same we have used, that is 560 ohm. R2 equal to 560. R3 equal to, this is 0 is there. Here 1 into 10K, that is called 10,000, plus this is 1 into 1K, that is 1,000. This is 0. 1 is nothing but 1 into 10, that is 10 here, that is 0 here now. So 10,000 plus 1,000, 11,010 here now. 11,010 ohm here now. Now we calculate R4 equal to R2, R3 divided by R1. R2 equal to 560. R1 equal to, sorry, R3 equal to 11,010 divided by 600. Calculate it. 560 into 11010 divided by 600. How much you got? 10,276.
10,000.
That is called
276.
10.2 kilo ohm. We can write like this. 10.2 kilo ohm, we can write this one.
Yes, sir.
Yes, sir.
So actually here, so the R1 value sums here. The knobs are missing here now. We'll get some data here now. So 3, 4, we are going to get that one. So for that reason, that 0.2 will be vary here now. 10.2 is there now. Here, you consider that one. 6. Again, you consider 8 here. No, 608 you consider. Okay, R1 you consider 608 means that will be changes here now. 560 into L1, L1, 01, 0 divided by 608. How much you got here now? Again, it is reduced here now. So little bit in the variation is also there in the knob. For that reason only the practical value, some variations are there. But the standard value we are using here, that is 10K. So the 10.1 you consider, that is this one 608 you consider here now. R1 equal to 608 here now. So that is 10.1K. The practical value is, how much is there practical? 10K. Theoretical is 10.1K. That is theoretical here now. These two readings you write down in the observation table. These two readings you write in the observation table here. You can go, madam. Any doubts? If you have any doubts, thank you, madam. किसी को कुछ डाउट है तो पूछ सकते. So these two readings we have to note down. The observation table where the R1, R2, R3, R4, that is called practical and theoretical. Two columns you make down here now. Here R1 value enter करो, R2 enter करो, R3 enter करो, R4 practical कितना है, theoretical कितना है. You have to enter and you have to write complete the write up part. If you want to ask anything, you can ask that one. Can I remove the connection? I want to see once again. One more value. Here, instead of this 560K, I will use this 1 kilo ohm. I will use 1 kilo ohm. Just I will show that one, how the galvanometer will vary that one here now. Here, the galvanometer is there in the different value, no? Yes or no? I will show full picture here. You can think that one here, the R1 is came to 0, but little bit is there here now. Here. It is 0 now. 0 है क्या देखो?
Yes, sir.
Okay, it is 0 now. So again, you can take the third reading. I will tell that one. So R1 equal to, how much it is there? I will consider here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 into 10, how much it is? 10 into 100 plus 1, 2, 3, 4, 5, 6, 6 into 10 plus 10 into 1, that is called 10 is there here now. 10 into 100, how much? 1000 plus 6 into 10, 60 plus 10 here now. So 1070 ohm, 1070 ohm is there. Okay. So R2 equal to how much we have considered here? 1000 we have considered. It is not 6 also, it is 7 here now. So 1080 you consider. 1080. R2 equal to 1000 ohm. किधर कनेक्शन किए? इधर 1 किलो ओम को कनेक्शन किए हमने. Yes? Yes or no? So R3 equal to 0 is there. 1. Only 1. 1 into 10 is nothing but 10,000 we have connected here now. 10,000 ohm. This one, all things are 0 here now. Calculate it now. R4 equal to 1000 into 10,000 divided by 1080. Calculate that. Calculate करो कितना हो गए? 9.2 आ गए क्या? 1070 करो फिर. 9.3. So little bit variation is there. We have taken here when the bridge is balanced condition, on that condition we have taken some extra. We have taken means exactly we will not get that one here now. Here, if we consider like this, exactly we have considered means that is not going to happen here. So exact 0 we are not going to get here. By variation it is moving here, but for some time it is going to move away from it, like that here now. So if the practical value is 10 kilo ohm we have considered, then the theoretical value we are going to get 10.0102 or 10.12, like that only we are going to get that one here now. Is it clear? So this is the only one practical we can do live session. All other practicals we are going to do in the virtual lab. Virtual lab से कर देंगे हम. Is it clear? If you have any doubts, you can ask. Suppose if you want to visit offline session, means after removing this lockdown and all the things, you can do and you can perform this practical in the lab also. It is available for all. You can come and you can see this kit. So many kits are available in our department. You can do that one. Any doubts you can ask. Another 10 minutes time is there. Oral questions may come on this one. You can write the formula for the that is Wheatstone bridge, and what do you mean by, what is the mean by resistance, bridge means what are the advantages of bridges. I told that which will give the main advantage of this experiment is more accurate answers it is going to give here. Research institutes especially, they are going to use the bridges and potentiometer circuits they are going to use. Any doubts? I'm asking to you people only. Will you complete the writing parts? Megger is already over. How many of you completed the Megger write-up parts? कोई complete किए क्या नहीं? We have completed the Megger experiment. Nobody has
Yes,
completed that. Okay.
Yes, sir.
Some people. Yes means no problem then. So you complete this part also, the Wheatstone bridge also. So in the next practical, we will do virtual lab only. These two only we are going to discuss on this kit and all the things. All other experiments are already available in the virtual lab. They are available. So we'll continue in the next. Okay. Just a minute. Any one of you have joined just now to the practical?
कोई अभी ज्वाइन किए क्या? Okay, absent roll numbers, I will call that one. Roll number 1. Roll number 11, 17, 19, 22, 23, 24, 25, 27, 31, 34, 35, 36, 37, 38. These are the absent roll numbers. If anybody is there, you can tell now only. Roll number 1, roll number 11, 17, 19, 22, 23, 24, 25, 27, 31, 34, 35, 36, 37, 38. Yes? Okay, nobody is there, I think. Okay, can I stop now? So this, whatever we have discussed, the Wheatstone bridge, it is not available in the virtual lab. For that reason only we have conducted in live video. So next, same formula we are going to use for all the bridges. R1 equal to R2, R3 divided by R4, or R4 equal to R2, R3 divided by R1. That is the unknown resistance. The third unit is similar to all experiments.
So majority will go to the third unit only. Wheatstone bridge is there, Maxwell bridge is there, Kelvin double bridge is there, Hayes bridge is there, Anderson bridge is there. Okay, so many bridges are there in the third unit. Can I stop here only? उसको भी yes नहीं बोलते आप लोग.
Yes,
Yes,
sir.
Okay. So observation table once again I will show. If you want, you can note it this readings also. Here it is there. This is observation table. These three readings also you can write down, no problem. You can take the screenshot also. Okay. To complete this write up part. We'll stop here only and we'll continue in the next class.